For this example, we'll be utilizing individual EWAS, TWAS, PWAS, or MWAS enrichment. As can be seen by the left-hand sidebar, we are at the MSEA or marker set enrichment analysis stage. For further information, you can click on the Click for Tutorial button, which will provide more details on the parameters that can be used in the marker set enrichment analysis. The first step is to upload or select a marker association file. If you choose to upload your association data, you must follow the sample file format, where 2 columns will be needed, with one as the header marker and the other with the header value. The marker can be an epigenetic probe, gene, protein, or metabolite, and the value should be your negative log 10 p-value. We also provide the option for gene identifier conversion. In addition, we provide our own sample EWAS, TWAS, and PWAS, and various disease EWAS. If you choose to select TWAS or PWAS, you can look for enrichment in marker sets directly. However, if you select EWAS as your option, you will have an additional step or the ability to use this additional step for mapping. If you select yes, you will be able to utilize our sample human EWAS mapping file. Or you can upload your own mapping file, but must format it in the same way as the sample file format here. Additionally, you can look to run marker dependency filtering. If you select yes, you can also use our example marker dependency for EWAS or upload your own correlation file as formatted here. You'll also be able to select the percentage of markers that you would like to include in your analysis. Finally, you will select the marker sets or upload your own gene sets. If you upload your own gene set, you will need to format your file with a header module and header gene. You'll also have the ability to add further information by adding a marker sets description, which will provide further context to your module name, but this is optional. For example, we will utilize KEGG pathways. Next is selecting the parameters for MSEA. We highly recommend to stick to the default settings, particularly in these cases. However, for more formal analysis, you may want to use a permutation type of 10,000, but for exploratory cases, you may want to use 2,000. For the MSEA FDR cutoff, this determines what significance threshold the module should pass to input to the next step, or key driver analysis. We recommend for formal analysis to use 5%, but leave the default at 25% for more exploratory analysis. Here we can see the files that we have chosen, and also the parameters that we have selected. We'd highly recommend for you to input your email address here. You can then run the MSEA pipeline. Here you can see that the MSEA is now running, and you'll be able to see in real time an update through the runtime log. Here the results have been generated, where you will see 2 forms of results files. One is the MSEA results, which are individually done, and here are the merge module results, where we have merged modules to reduce redundancy based on the previous page's parameter of a 33% overlap. Here, for convenience, we have shown a table with the module results, where you can see the module name, the p-value and its FDR, the genes, the top module genes, the top markers for those genes, and the module top association scores. We also have a search tab where you can search for a given pathway. We also have our merge module results. where if any pathways did meet the 0.33 threshold, they will merge. And this is indicated by the comma dot dot. And you can see in the overlap section, the pathways have merged.
Having completed the MSEA analysis, you'll now have the ability to pick between going to the WKDA pipeline or continuing to drug repositioning. For this example, we're going to go through the running of the key driver analysis. As you can see on the left-hand side bar, we are now at the KDA stage and we have skipped over the MSEA to PharmOmics option. Again, we have a click for tutorial button, where if you select this option, you can see we provide further insight and comments to each of the files as well as parameters. The first type of file that you can upload or select is the network for the key driver analysis. If you are going to upload your own file, you must follow the sample file format, where you'll need 3 columns with the headers head, tail, and weight in this capitalized form, with the corresponding genes and weight value. Additionally, you can use from any of the constructed networks that we provide, where we have numerous Bayesian tissue-specific networks, as well as combined network, where Bayesian are gene regulatory networks, Giant are another form of gene regulatory networks, Phantom 5 are a transcription factor network, and finally, the string PPI network is a protein-protein interaction network. We'll select this as an example. Next is the parameters that you can select for the key driver analysis. We highly recommend that you stick to our default values that we have already input for you. And if you would like further information, you can always read the comments on the side. But quickly, the search depth determines the search distance used to define the key driver's local network neighborhood, where 1 refers to 1 connection away, 2 would refer to 2 connections away, and 3 would refer to 3 connections away. We'd recommend to use 1, but you can increase this to 2 or 3 for more sparse networks or for smaller input gene lists. The edge type is if you would like to consider directionality in your network, where you would choose directed for this if you would like to consider directionality, or undirected if you wouldn't or don't want to consider directionality. Next is the min hub overlap, which is the ratio threshold above which hubs will be considered co-hubs, and we'd recommend to stick to our default value of 0.33. And the last parameter that you can change is the edge factor, and this is the degree of influence of the weights, where 0 would be no influence, 0.5 would be partial influence, and 1 would be full influence. If you're uploading an unweighted network, then you should select 0. We can then proceed to review the different files that you've uploaded, as well as the parameter that you've set. Once again, you should upload your email and send that email so that you can be notified when this job is completed, and then you can run the key driver pipeline. You can now see that it is running, and you can follow this in the runtime log. Upon completion of the key driver analysis, you'll come to the results page, where you'll be able to download each individual result on its own or individually, or you can download all of these results in a zip folder, which we highly recommend to utilize by selecting this button. For convenience, we also provide this table where you can see the list of the top key drivers. You can also see the pathway that that key driver is associated with, the p-value of that key driver, the FDR of that key driver, the genes within the given module, the number of subnetwork genes for that key driver, module and subnetwork overlap, fold enrichment, and finally, more information or descriptions on the given module. If you would like to search for a gene of interest, you can type that gene in, where you'll be able to find information on the FDR and p-value of that given gene, as well as the pathway that it is associated with. You can also continue to the Run PharmOmics option for drug repositioning of these key driver results, or you can go and display your key driver network using our visualization tool. In this example, we will continue to display the key driver subnetwork, where you'll be redirected
to a new tab. This new tab will provide the visualization of your network. You'll have the ability to download the JSON file, take a screenshot of the graph. But you'll also have a legend here that will signify what each of these shapes and colors represent, where the diamond shape signifies a key driver node, and the circular shape represents just a given node. The color is important as this will signify if it is a non-module member, as in the case of the small gray node, or part of a module, signified by one color. If it is part of multiple modules, then it will be multicolored. The key driver border color signifies the module that the key driver is a top key driver of. The colors represent the pathways that they are associated with. If you would like to change the layout of your given network, you can manually do this by selecting the nodes and placing them in the position desirable to you. Or you can use this active layout option, where you can select different forms of layouts, such as the concentric layout.
Upon completion of the key driver analysis last time, we chose to display the key driver subnetwork. In this example, we will go through inputting the key driver results into PharmOmics. To do this, you will select this button. Upon selecting this button, you'll be led to Step 3B, PharmOmics, where you'll have the choice between selecting overlap-based drug repositioning or network-based drug repositioning. We will select network-based drug repositioning. Here, you'll be able to select a network or upload a network. In this case, we will use the sample multi-tissue network. We also have the option to choose from human or mouse. In this case, we will select human as our data is derived from humans. Here you can select specific genes and modules from the subnetwork to run drug repositioning analysis. You can select all genes from the subnetwork, all genes from input modules in the subnetwork, genes from specific modules in the subnetwork, and significant key drivers that pass an FDR of less than 0.05. Here we'll use all genes from the subnetwork. You'll be able to click to review, which will show the custom network's been selected, the species, the module and gene selection, and again, you'll be able to input your email address. We can now run the analysis. Upon completion of the network-based drug repositioning analysis, you'll be able to download your output files by selecting the download options here. You can also see in this table the drugs, the species that those drugs were tested in, and the tissue. In addition, we provide the z-score, the rank, the p-value, and network files that you can download the edges and the nodes. Additionally, you can display the network by selecting any of these links. Upon selecting the display network option for your given drug, you'll be redirected to a web drug network visualization, where you will see your input genes are highlighted in red, and your drug genes are highlighted in blue. If a node is both an input gene and a drug gene, it will be split color like so. You'll be able to manually manipulate this network by selecting the nodes and moving them. You can also download a JSON file. You can take a screenshot of your graph. You can also change your layout by selecting these options like so.